Hello everyone and welcome back for video 7 of function operations, composition. In this video we'll be writing composition instead of just evaluating. So we'll actually be composing two functions together. This is called part 1. There will be a part 2. We'll use a little bit more difficult functions in part 2. So let's go ahead and see what functions we have here. Now you may remember these guys, f of x, which was in video 3 for multiplication part 1, 6x minus 5, and g of x, negative 3x plus 8. So we want to compose these two functions together. And in case you've never seen composition before, you might want to go back and watch video 6, which is evaluating. Goes over a little more basics of the notation, but just a little recap. The notation for composition is an open circle. And the way we would read this is f of g of x. And what I like to do when I'm composing functions is the first thing I'm going to do is I'm going to write it in the other notation. I'm going to take whatever function is on the right and I'm going to write that function down. So here I have g. In this case, we're evaluating it generically for x, so g of x. And then what we do is we put a set of parentheses around that, and we're going to take the function that's to the left of that, and that function is going to go on the outside. So f of g of x. And the reason I like to write it like this is because what I can do now is I can look at this notation and just ask myself, what do I know? Working inside out, what do I know? And what I know is I know what g of x is. It's right here. So what I want to do is I want to rewrite this notation, but in place of g of x, I'm actually going to write what g of x is equal to, which is negative 3x plus 8. So I'm rewriting that notation, and I'm going to plug in the actual function g of x, which is negative 3x plus 8. And then what I want to do is kind of what we did when we were evaluating functions. I want to take what's in the parentheses here, and I want to substitute that in for x for whatever function is on the outside. So in this case, I'm going to take function f, and everywhere I see x while I'm writing f, instead I'm going to substitute in negative 3x plus 8. So 6x instead of x, it's negative 3x plus 8 minus 5. And once I do this, what I need to do is simplify this. So I'm going to go ahead and follow order of operations and simplify. The first thing I'm going to need to do is distribute this 6 in. I don't want to leave it like this. It can be written a little nicer. So I'm going to distribute that 6 in, and that's going to give me 6 times negative 3x, which is negative 18x, and then 6 times 8, which is 48, and then minus 5. All right, so we're going to go ahead and multiply that 6 into that set of parentheses. And from here, I'm going to simplify this, kind of like what we did in video 1. We're adding, we want to combine like terms. There are no other x terms, so that negative 18x is going to stay like that. But the two constants can be combined. So plus 48 minus 5 is plus 43. And we are now done composing f of g of x. And that gives us negative 18 plus 43. Now I know what you're thinking. F of g of x, great. What about g of f of x? Let's take a look. Here we have the same functions. Now what I want to do is I want to ask myself, does anything change if I switch the order of these two functions? What happens if it's g of f of x instead? Let's go ahead and take a look. I'm still going to do the same process. Let's see if anything's different. So I'm going to take, again, the function that's on the right, and I'm going to go ahead and write that function down. So f, and we're evaluating it for x, and I'm going to put that in parentheses, and then I'm going to take the function on the left, and I'm going to put that on the outside. So g of f of x. And again, the reason I like to write it like this is because what I do is I take what I know, and I work from inside out. Do I know f of x? And yes, I do. Right, it's written up here. So I'm going to rewrite this. Right, g is going to stay, but instead of f of x, I'm going to write what f of x actually is, which is 6x minus 5. Right, and what I'm going to do now is the same thing I just did. I'm going to take whatever function's on the outside, which is g, and anywhere I see x, I'm going to substitute in 6x minus 5. So what ends up happening is we take the inside function here, f of x, and we kind of nest it inside the outside function. So I'm going to take that function g, and anywhere I see x, I'm going to put in the f function, which is negative 6x minus 5. And this is going to get simplified similar to the last one. We're going to go ahead and try to distribute in that negative 3. So negative 3 times 6x is negative 18x. And I'm also going to multiply it by the negative 5. So negative 3 times the negative 5 is plus 15. And we're also going to have that plus 8. And then from here, what we're going to want to do is combine like terms. In this case, I don't have any other x terms, so that's going to stay as negative 18x. But I can combine 15 and 8, which is 23. So plus 23. And that's going to give us g of f of x. And if we zoom out here, we can see that these two compositions are not the same. G of f of x is negative 18x plus 23, but f of g of x is negative 18x plus 43.